once I get the TV in the back set up, we're going to get started. Make sure your answer's in the computer.
Wait, is that TV not working?
I just haven't set it up yet. No, sorry. It's my geometry students. We're studying something called bivariate data. And so there's an activity that I do with them with bivariate data. So it's not that they're special. I still like that. The lesson goes well. Alright. Stop at the poll. So we need to get our answers in a little bit more quickly. So a couple of things. Area is equal to base times height. Base multiplied by height is area. Okay. Calculating tables. Constant multiplicative. What is that person referring to? Constant multiplicative.
Exponential.
Well, the constant multiplicative starts with an R.
Rate of change.
Rate of change, which goes with what type of function, Deja? Exponential functions, right? So constant multiplicative rates of change go with those exponential functions. Graphs help justify graphs and tables, right? Remember, we're trying to, one, find evidence for y, which we already discovered it. What were the best dimensions for that plot of land? 25 by 25, which a lot of us were like, can I even use a square? Yes, a square is a type of rectangle. A square will always give you the best or the most area for a given perimeter. And so the graphs and the tables help us justify that. One of the things I do want to make sure is I'm going to have y'all actually, the table stuff on the calculator, I'm actually have y'all redo that today because is it fair to say that we need more practice with doing that skill? Yes.
On the calculator?
The calculator part of it. So we're going to redo that today in class. It's going to be with the same exact content so that there's not any surprises. I just want you to get the practice in creating those tables. Okay? So we're going to do that. Yeah, we're going to do that now. I'm trying to look see if there's anything else that was up here, but that's about it.
Who else did the table?
Who else did what? All right. So here's our agenda for today. We're going to wrap up Lesson 2 Gold Rush, quadratic functions. We are then going to do linear, exponential, and quadratic functions Venn diagram. And I'll go ahead and tell you this. For those of y'all, Asia, can you let James in, please?
James.
Fair enough. Good afternoon, James. There we go.
Oh, let's go, James.
All right. So, what I want y'all to hear me very clearly on is this. For those of y'all who said, hey, Mr. Kinney, my brain is tired, you didn't even see your first block, shouldn't we just have a break today? The answer is not entirely, but if we finish the Venn diagram, or when we finish that Venn diagram, we will stop today, because that's where first block got to yesterday. Okay? So, if we get done early, y'all have a little bit of free time. Not, you can't go buck wild or anything like that, but we will have some free time for y'all to chill. So I knew, for them at least, that I was going to see them today, so I actually did more direct instruction with them and less of the exploration that y'all did. So I let y'all work more than I let them work. Yeah.
Wonderful Thursday.
Right? Okay, so we are studying linear, exponential, and quadratic functions, which is why we need to go back to this idea. At its core, what is mathematics? Study of patterns and relationships, right? We already discovered it with a linear function. What was the pattern at play? With a linear function. Constant additive rate of change. Constant addition, constant additive rate of change, which we call that a, what was the name of that rate of change, huh? Slope, right? So remember, that's the idea of slope that you've studied in the past. That's that constant additive rate of change. Then we got to the exponential function, which had what type of rate of change? Constant multiplicative, which we call a constant factor, right? Remember, you multiply with factors. So we're looking for those patterns and relationships, and today we're getting further into, and we should wrap up, the rate of change that defines a quadratic function. We need to understand how quadratic functions appear in tabular, graphical, and algebraic representations. Those are the two main ones right there. And we've already started to look at the graph. We've already started to look at the table. We have the graph for the most part down. There's not a whole lot we need to add to it. We need to look further at the table and further at the algebraic. And we're just going to begin writing the explicit. And I'm going to talk about explicit versus recursive a little bit as well. Before I get there, because before I forget, who does not or who will not have an iPad tomorrow?
Interruption. Kamari Hood, if you're in the building, please report to the office. Kamari Hood, please report to the office. Thank you.
Yeah, they don't have it.
Those are problems I can't handle, but what I can do, you will need your iPad tomorrow. If you didn't hear me on Monday and Tuesday, I'll be out. Miss Esta will be here on Monday as the sub. And I have picked an activity off of what's called Mathia, the online part of Carnegie Learning, that's going to help you practice writing linear and exponential equations. Because I know that's a skill that we need to develop further. And so she will be here to help support you as you work through the system. While I'm out, you're also allowed to work with the people in your small group. Don't go outside your small group, but work with each other when you get stuck. And I'll show you a lot about the system tomorrow so that you can be successful. This is a system also that you'll be able to access through Clever. And so there will be homework assignments now that we're starting to get our iPads, once everyone has their iPad. We'll have our homework assignments through there. So, Maddox, did you start to raise your hand?
No.
What's up?
Are you gonna teach us how to calculate graphs today?
Calculate graphs?
You know, like,
Like how to graph it on the calculator? Somewhat, yes. Some of the things, not all of the things, but yes. So that's one of the things. Okay, so only 7 of us need iPads. Just raise your hand again if you need an iPad, just so I can make sure I have the count right. 1, 2, 3, 4, 5, 6. You need an iPad too, right? Okay, those are the only 7. Oh, and 8. You need one as well, or you don't have one? So I'm going to get MacBooks for those from the library who need iPad, or who don't have their iPad. Okay, Gold Rush. In the 19th century, many prospectors traveled across North America to search for gold. I don't know why I'm reading this. We already read through it yesterday. So we have our Gold Rush task. We already went through this number 1. We found the dimensions would be 25 by 25. And we have justified those dimensions. We've justified it tabularly, right, by looking at that table. And we started to justify it graphically. Now, I will remind you, what was the last detail with the graphing part that we need to pay attention to? The spacing. Remember, I think I saw a lot of people yesterday when they created their graphs where they went 0 and then 225 and then, was it 400? Right, but those can't be the same space. Yes, Aaliyah. You don't have this from Tuesday? You didn't put it in your notebook? It should have been with that Venn diagram. Do you have your, look at your notebook, where's the linear and exponential sheet, the dream job salary? I can find a copy for you if you don't have it, but you should have picked it up on Tuesday.
I did. It's just not anywhere.
Okay, how about this? Let me get class started and I'll print it out for you if you can't find it, okay? Alright, so remember when you're graphing, what do you need to make sure you do with the graph? If you're graphing by hand. Right, we can't go exactly the numbers we want. We have to go the same spacing every time. So what spacing did we use? Hundreds, right? 100, 200. By the way, if you haven't already put this graph on the backside, you should definitely do this. I will also make this note. What can make your job graphing easier? Well, yeah, a calculator can make it 1,000 times easier, but if you're doing it by hand.
A ruler.
Yes, a ruler, but there's even something more useful. Oh yeah, graph paper would be very helpful, wouldn't it? So I have some graph paper. I don't think I put it out. I'll get some graph paper from the back if you want this moving forward. But when you graph by hand, graph paper helps significantly. Yeah, you see where it says extra notes?
Yeah.
That's where you want to write this. Okay, so we went by 5s. Does that sound right? Sorry, I should have had this already set up. Alright, was it 0, 0, 5, 225? 10 was 400? 15, 525? Somebody please tell me if I'm right?
Right. Yes.
Okay, 20 was 600?
No, 20 was 600.
Yep. 25 was the 625.
Correct. It's like
Okay. 30 was back to 600.
yeah. Now it's just the same. Yeah.
Whatever it is, just put it over there and I'm not dealing with it.
It's the stuffed animal.
It's a stuffed animal?
Yeah, it was my
It's
baby
not
today.
Okay, if I hear it again, it's going on the back counter so that no one can press it and make it go off. Alright, 40 was 400. 45, 225. 50, 0. Alright, so there is the function that we have. If you weren't here yesterday, you will want to graph this by hand at some point. We'll also look at it on the calculator. But one of the things that we will look at is once we smooth it out. So one of the things that I heard a lot of students say yesterday was that this was the normal curve. But if this is a function, I want you to notice how I drew arrows down. Does that still look like a normal curve? No, right? The normal curve, remember, it goes out because there's those points of inflection. Because notice, I want you, what's the shape? First off, this is called a what again?
Bell shell.
Parabola. Remember, the normal curve is the bell shape, but this is a parabola, and it has what concavity?
It's
Concave down, right? This would be concave down. The normal distribution, remember, changed from concave down to concave up at that point of inflection. That's where we knew the standard deviation was, or one standard deviation. Okay? And because this is concave down, we have what kind of point right here? A maximum, right? And so we would want to recognize, okay, I have a concave down parabola, so there's a maximum for this function. And you would say that this is a maximum of 625. The maximum is always the output, but we say it's a maximum of 625 at x equals 25. So the maximum is the output, but it's located at that input value. That's more for a later unit, but it is something good to be aware of. Alright, so parabola, this one's concave down. Obviously, the parabola can also be concave up. And if you have a concave up parabola, you would have
A minimum.
a minimum. And that point, that minimum, that maximum, they're each called the vertex of that parabola. And the vertex will either be a minimum or a maximum based on whether it's concave up or down. And so we'll get into more of that later. What I want you to do at this point, especially for those who were absent yesterday, work with them, I'll be moving around the room. I actually want you to go back to the table on the Gold Rush task. So first off, if I create a new document, what type of page do I need to create?
4. Right.
List and spreadsheets is how we create our tables. Work with those in your groups to recreate the table both ways that we did it yesterday. We want to get both the recursive and the explicit methods down so that we can get more practice with it and be more successful. What are your questions at this point? Tristan?
Are you assigning a document?
So I would start a new document, yeah. I would start a new document, I would recreate it. Don't forget, what do you need to put here at the top?
Base high area.
Remember, you need to name these.
Can we just do like B1?
So here's the only issue with doing B1. It's a good question.
Miss S is only B1.
I know, but she hasn't dealt with this as much as I have, and there's going to be one goofy thing that shows up. If you think about it, isn't B1 column B, row 1?
I didn't think about that one.
So the calculator will ask you later, hey, is that a variable or is that a cell reference? If you type out base 1, it knows that it's a variable. Okay? So I shy away from doing a letter with a number because of that issue. So I do base 1, height 1, and area 1. The 1 is because you're going to have to do all this a second time, and you want the 2 in there for that second method, right? So remember, there's the recursive definition, and then there is also the explicit definitions of this. So work on doing that again. Work with your small groups to get this completed, and I'll be coming around to support you. Tristan, any more questions? Okay. Any other questions before I let you work in your small groups? Yes, EK.
What do you mean by recursive?
So, okay, does anyone, before I answer the question, does anyone remember what I mean by recursive? So when we drag and dropped the formula through, that was a recursive definition. So like right here, the first value for base was what? 0, right? And so when I came to the second cell here, A2, I typed in equals, and then what? I would click on that cell, which would be A1, and then what? And you can do +1. Let's go ahead and just do the +5 so it takes a little bit less time. But notice I would type that in. I need y'all to pause. I need you to pay attention to this. The reason why this is called recursive is when I drag and drop this through, even though I don't have to type it out each time, if I were to come to this cell, A3, it would automatically make it what? A2 plus 5. Do you see how it's always being defined by the previous number? That's what we mean by recursive. So even though I don't have to type it, for A4, it would be A3 plus 5. And so it's always going to the previous value. Whenever it's a recursive definition, it's just going to the previous number and then getting the value from there.
Is that the icon?
Say that one more time.
Is that the number for the
Base. It doesn't really matter, it'll work either way. But you go to base 1, and so you put your 0 to start, because you need some starting case. And then you type in equals. Actually, I'll come over and I'll help you in a second, because I know you're gone yesterday. And then I'll check on you first after that.
We're going about 5.
Go by 5s for now, just because it'll be a little bit quicker. It doesn't change anything about how you approach it. All right, let's get to work. Okay, so, yeah. Does that mean, you were here when we first, we did this a little bit on Tuesday, right? Oh, so you just did the, yeah. So she just did the base starting at 50, and you can do that and go down. I was just starting them at 0. But if you started this at 50, right, then you would have to type in equals, and you would click on this, but you want to go down with the base value to subtract 5. Well, so here's the thing. So you drag and drop, right? If you start with a base of 50, right, the thing you missed yesterday that we need to be aware of is you only have 100 meters of rope. So if the base is 50, so this is 50, this would be 50, that's all 100, isn't it? So then your height would have to be 0 and 1. So notice how I started at 0 for the base? Well, you're starting with a height of 0. And then you would need to, instead of subtracting now, you would add 5. So when the base is 45, the height is 5. So you just have it flipped. It's the same thing. Does that make sense? Okay. So y'all make sure you help out Zany because she was gone yesterday.
That's where like
What do you mean the other one? Page? Okay, so don't forget when you need to add another page, hit Control Doc. Hold on, escape. So, because what you have typed in right now is equals 0 plus 5. So what that's going to actually do is always give you 5, because it's just 0 plus 5. What you actually want is, so you click on the previous cell. So not just the number 0, A1, because that's the number 4. And then you would add 5 to that A1. Now, this is what I was referring to, so now when you drag it, so like if you click right here, because I said A2 plus 5, so it went to the previous one, 8, so A4 is A3 plus 5. That's the idea of a recursive definition. Okay, did you?
I did.
You don't know where they are? Do you want me to print them out for you? Okay.
I got it because I was bad.
I got you.
Oh, yeah. how you did it in that. Yeah.
I forgot how to do it.
So like, was it all for you? So you put the phone on.
Tristan, are you doing bird methods? What if we do group?
I can tell you.
Yeah, figure it out.
You missed some good communication over here, Mr. Kenny.
I believe you, but I gotta take care of other things really quickly. Keep working.
I want my 5.
I want to.
So you can do that. That's more the explicit. Are you doing the explicit right now or the recursive? Because it looks like you did a recursive for this height. So just do the recursive on that page and then do the explicit on its other page. Yeah, the explicit, so the recursive, remember, is when you refer to 2 different values, right? And so like when you did equals and you went A1 times B1 and got this, that was more the recursive idea. For the explicit is when you type in that equals at the very top. The explicit is when you type in equals at the very top. That's explicit right there. Yep. So now do your recursive though. Now, one thing I will say is this, you did recursive for the height and you did explicit equals for the area. No, I mean, that's fine. I'm just pointing out that you did do recursive already for the height. You need to do an explicit now for the height and recursive for the area. The explicit for the height. So remember yesterday we looked at the fact that the base plus the height was equal to 50. So we needed an expression for what the height was equal to. So remember how that gave us an explicit equation with an input of base, output of height? Hold on 1 second. How y'all doing?
So for the second one, I wanted the area, but I don't know.
Did he go all the way down?
Base times height. Right.
But what do you do for this one?
For the height? Well, so for the base, you have to start off recursively. The other 2 you do explicitly. So you have to have a starting, because remember, you need an input, right? And so your base 2 is your input. So define that recursively. You still start off with 0, you define that recursively, and then you go to, then you can do the explicit. Excuse me really quickly, because I was not clear about this. You always, hold on, listen. You always need to do the input recursively, right? So you have to define your base recursively, but the explicit part comes in with the height and the area you can do explicitly. So if you look at the top up here, remember this is where you would type in an explicit equation. So if you can figure out an explicit equation or expression, you type that in up here. Let me check on these groups and then I'll come back around. I mean the ones and five, the ones aren't an issue. 1 versus 5 is not a problem. What I want y'all to consider is the explicit versus the recursive. Right, so remember the recursive is when it always is defined by the value before it. But for an explicit, you need an equation for height based on the base. So that my base becomes my input, and I need an equation for what the height would equal in terms of the base. Does that make sense?
Yeah.
Work together. Don't look at it like that yet. Talk with each other first. Okay, so you need an equation for what the height is equal to based on what the base value is. So what's an equation that you automatically know, we should know quickly? Base times height is area, yes, but I can't use that because it has 3 variables, right?
How do you get out?
What's the relationship between the base and the height? They always did something. Remember, we had 5 and 50. They don't equal 50. I think he said that yesterday too. They add up to 50. So we always know that base plus height is equal to 50. Use that to figure out what height is equal to. Alright, Jake, you had a question? So you would if you have an equation for height to an area too, but you need your base to be your input. Right? Okay. Did you say? Hit current. Yeah. get your tables going. Let me know if you have questions or really talking to you. Y'all good now? Making sense out of it? Okay. Is someone from group 2 asking us? Okay, hold on one second.
So it'd be like equals.
That's the explicit.
Oh, that was explicit.
They're both explicit. So remember, so what an explicit does is it takes an input, the base, and it gives you an output. So when you type that equation in, it automatically gave you all these values because it took that input and put it in here to get an output. The recursive, okay, actually, the recursive.
For the first one?
Yeah, I figured out how to do it, but I don't know how to drag it.
This is recursive. You see how it's referring to the previous value and then subtracting 5? That equation is recursive. You see how it says 82 minus 5, so it's referring to the previous value of 45 and then subtracting 5. So you did it, remember I told you did it for your height, you did recursive, right? So make another page and do your height and the area recursively. Because I just want you to be aware of how you don't have to do it both ways every time. But remember how with standard normal curves and z-scores, I taught you how to do it with tables and with the calculator? So you won't do them both ways every time. It's to be able to do either way. So a recursive definition is really easy on a calculator, but it's really hard to do a recursive definition by hand, because let's say that I have a sub 2 is equal to 8. So the second term is 8, right? And this is how we would traditionally define a recursive definition. So this is telling me that I'm repeatedly adding 7 every time, right? So the current value is equal to the previous plus 7. But now I want the 50th term. Well, I would have to add 7 48 times. I have the second term, I want the 50th. I have to add 7 48 times. So recursive definitions are not useful by hand. So I want you to practice doing recursive through the calculator, but then explicit also works well. Does that make sense? So it takes practice. So make sure you check it out. You stuck on the explicit one?
I don't know.
Any of it?
Numbers.
Okay. Work with that then. She seems very excited to help you. All right, so Zane, what's up? Huh? The explicit one? So you did on the recursive? Did you check with everyone else on the recursive? Well, I mean, it takes time. So these numbers, remember, the idea is that we're looking at trying to create the biggest area possible when you only have 100 meters to go. So when you went 50-50 on the base, the height had to be 0. Well, when the base is 45, when the base is 45, if I put 5 here, notice 45 plus 5 is 50, plus another 50 is 100. So what we discovered was that the base plus the height always had to add up to 50. So that's how we got our base height, and then area is just base times 100. Does that make sense? So we did that in the calculator by using that recursive definition. So you took base and you multiplied by 100. I'm going to show everybody in a second how to do explicit. So get your base in there. All right, for some of us, hold on. For some of us, we are struggling a little bit with the explicit way of doing this. Make sure you have your base in there. I think everyone's got the recursive, but have your base in there. So base 2, type in height 2 and area 2, and we're going to go over the explicit in just a second.
I figured it out.
Here's a better question though. Have you made sure that everyone speaks now? Actively collaborate. That sounds so demeaning the way you said that.
Really?
Hey guys, let's
let's figure this thing out together.
There we go.
Let's help.
Take that iPad away.
I would.
Know what kind of
It's a
Not a
caribou.
Highland bull.
It's a caribou.
Alright.
It's a
Are we good on both recursive and explicit
Caribou.
across the board? Okay.
What is it?
Alright. So, let's look at this. Don't forget, the first input always, or the input always has to be recursively defined. Alright, so base 1, height 1, actually, sorry, this should be 2, but whatever. Area 1. Alright. Now, we went by 5s, but could you add 1 every time?
Yeah.
Very much so.
Football.
Yeah, I'll do my 5s.
This is the second one?
Yes, this is the explicit method. Okay, so here's the thing. In order to do it explicitly, you need an equation that relates inputs and outputs. So we needed an equation that only involved base and only involved height. So what is an equation that we could write from the information given about base and height?
Say it again.
What is an equation that we're able to write immediately that relates base and height? B plus H equals 50. Anybody want to add on to that or push back on that? Or ask a question about that? Say it one more time. Say it louder. Okay, so we're going to get to that in a second. So we didn't have that equation right away, but B plus H was equal to 50. Because we know if we take one base and one height and add them together, that's 50. So the second base and height together would be 50, which is a total of 100. And so Evan, what did you get? 50 minus B is equal to H. Can anybody remind us algebraically how we can get from this top equation to this bottom equation?
What do you mean by
Inverse.
Take it. Minus B. B minus B is 0. And we talked about this a little bit originally, but I want you to notice we want H on its own, so I need to make the B a 0. Okay, we're going to come to that in a second. Don't forget, when you're adding and subtracting things, what number are you trying to create?
0.
0. When multiplying and dividing, you're trying to create a 1, right? So that's a big thing to keep in mind. And Clay already mentioned this. Whatever I do to one side of the equation,
Have to do the other.
I have to do the other side. That's known as a property of what? Anyone know? When I do it to both sides?
Property of math.
Distribution.
So this is an inverse to create a 0. When I do it to both sides, though, that's called a property of, not distribution, equality.
I should have said that. That's what was in my head.
Okay? What a property of equality does is it creates an equivalent equation. So that idea that you've always, you don't have to write this down, but you're going to hear me talk about this a lot because it's an important idea and it will show up later in this unit. So let me finish writing this. A property of equality creates an equivalent equation. What I do to one side, yes, I have to do to the other. That's a property of equality to do this thing. Because here's the idea. Does B plus H equal 50 and 50 minus B equaling H? Do those look exactly the same?
Yes. No.
No.
Do they look exactly the same? No. Do they mean the same thing? Yes. That's the idea behind equivalent equations. They may look different, but they're telling me the same story just in a different way, which is useful here because now I know, oh, height is exactly equal to 50 minus the base. And so we want equivalent equations so that we can work with them. And so right here under height, now I know 50 minus the base. Remember, I want the height. So equals 50, and don't forget, you can type out base 1, but what button can I click? VAR, that stands for variable, right? VAR is right above the number 9. This is why you want to label those columns. And so I type in I click base 1, and I want you to notice right now, is there anything in that column? No. And I hit enter, and it automatically fills it all in. Because this explicit equation, what's happening is The calculator is taking this input, substituting it in, and getting this output. That's what an explicit equation does. You take an input, you substitute the input in, you get an output out. Okay? Now, I'm not going to spend a long time on this, but I do want you to show. I want to show you why this matters, because Addison asked a great question in the small group earlier. He was like, "Why do I need to do both recursive and explicit?" Right? Yes. Okay. And so here's the thing: the calculator, recursive definitions are super easy, but recursive definitions are not super easy to do by hand. For example, this is just making up a situation, but let's say that I know that the second term in a sequence is 13. And then this is the recursive definition. What this is saying is that the next value, the nth value, is equal to the n minus 1 value. So whatever was right before it, plus 8. That just means I'm adding 8 every time. Does that make sense? It shows up. So it'd be easy to get the third term, because what am I going to do to this 13? Add 8 and get 21. It's easy to get the next value with a recursive definition. But what about if I ask you for the 67th term? What would you have to do? Not 67, because I already have the second. So I'd have to add 8 65 times. Okay? Do you want to add 8 65 times by hand? Not particularly. Do you want to, because you could also have it times 8. Do you want to multiply by 8 65 times by hand? No. You can even have things other than constant rates of change. So a recursive definition is not great when we are trying to work things out. You will want explicit equations to make sense out of this. This equation, the original plus 8, explicitly would be f of x equals 13 plus 8 times x minus 2. Now, if I want this 67th term, I can just substitute 67 in, and it makes my job really easy. Because notice, what's 67 minus 2? 65. Notice how I have 8 times 65? Because what's multiplication? Repeated addition. So this explicitly adds 8 65 times. That's why you would want an explicit equation, because it's going to make your life easier. Okay? So that's where this matters in terms of making math easier to access. Yes, ma'am?
Why is like the number under the 8 when it says 18 equals 7? Why is it under?
Right here.
No,
A2.
yeah, why is it?
Okay, so that's known as a subscript. What this is doing is a lot like, so we use this notation in what are called sequences. Functions are continuous, but you notice that right here how we have single points before I drew that curve around it? Sequences like this are just isolated points. They're called discrete points. There wouldn't be a smooth curve. And this is traditional notation for that. It's the same idea as saying f of 2 equals 13, just meaning that the second value, or the second number, has a value of 13.
So what's that?
It's just defining a sequence. So you know how we have f of x defines a function? The a defines a sequence. So it's just saying that you have a sequence. That's all it's saying. And within that sequence, the second number is 13. So, okay, you can also write out sequences by hand. If the second number is 13, and we're adding 8 every time, the first number would have been 5. The second number, 13. The third number, I add 8 and get 21. Add 8 again, I get 29. So notice how this is just the first term. So if I'm adding 5 every time, so remember I only had the second term. So in order to add 8 and get 13, I had to start with 5. So I figured it out because of that rule. But notice how it's just telling me which term it is in the sequence. The first term is 5, the second term is 13, the third term is 21. That's what the subscript is telling you. The only reason why I will not test you on this, let me clarify. But you will see stuff like that on standardized tests, like the ACT. it shows up. So it is something to be aware of.
So bad.
Yep, we're going to try to fix that as much as possible this semester so that it is not so bad in the future. Okay, so for the area, what can I type in as an explicit equation?
Base 1, I mean base.
Base 1
Base 1
times the height 1.
Yes. Equals.
And so remember, here is more evidence, right, that the best dimensions are 25 by 25 for an area of 625. But here's where it gets to be important, and I need you to pay attention to this. Because when we talk about functions, how many inputs are we going to have? If you have a function, in my class typically, I don't think I'll ever make you have more than one input. What I mean by that is, think about the exponential equation. What's the input for that equation? X. That's only one input, right? When you think about the linear equation, what's the input? Not mx plus b, just the x. Remember, the m is my slope, the b is my y-intercept. But just the x is my input. We're going to get into functions that look like this. And a, b, and c, and d, those are either coefficients or constants. What's the only input for that equation? X. We have x being cubed, we have x being squared, we have just x to the first, but the only input is x. So for me, for the most part, functions are only going to have one input. Functions can have any number of inputs, but for our class, we're going to focus on one input. And so when we look at this idea that the area is equal to base times height, how many inputs are there for that equation? There's two right now, base and height. Is there a way to rewrite that though, so that there's only one input? Say again? Well, I need to rewrite that BH. Okay, so I want to extend this challenge to you. You already know the answer, even if you're not aware of it. I will tell you that it goes back to the idea that b plus h is equal to 50. Take just a couple of minutes, try to figure out how you can use this equation to make this be only one variable. Just take a couple of minutes. Actually, I'm going to be nicer to you than that.
You're going to be even nicer?
Yeah. B plus h is equal to 50. We already know that, right? What's an equivalent equation to this? What is equal to h?
H equals 50 minus 50.
That's an equivalent equation. If you can figure out how to use that equation and this equation, you can get the area equation into one variable. Take a few minutes with your small groups, see how you can use those two equations to get one variable for your function. Calculator's not going to help you if you can't think through it on your own.
Okay, y'all. I'm trying to think. So you said I think. Well, since you're always gonna volunteer. I think.
Can you read the question again?
Use h equals 50 minus b and area equals b times h. We want this equation to only have one variable.
Okay.
How can I use that equation to make this only one variable?
You can do wrong. It didn't make sense.
It's just inaccurate. It's not supposed to be.
Yeah.
Oh
my gosh.
I want to be precise.
Everyone's irritated. You see that?
Are you? So you're just like, or what are you like?
We're about to go back over. Alright, yes. We're just going to have a conversation. Alright, so at this point, has anybody figured out a way to get this equation into just one variable? Okay, what do you mean by that?
Either one you can
divided by b, maybe, like that. So area divided by b is equal to h. And so what we want is the area formula with only one input. Does anybody want to push back on or add on to or ask a question about that statement? So think about it for a minute. We're just trying to grow and learn together. Anybody want to push
Do you
back
have
on?
to do base? Does it have to be?
I just need an equation for the area that has only one variable.
Like,
The H to
if
B.
that include like,
Hold on a second. Kennedy, say it again.
you can't have Y.
You could have y just represent one of those variables.
It does count.
It could. Yeah. Lexi?
Are we trying to plug in numbers?
So we're going to want to be able to substitute a value in for something and get the area out, right? We want just one input.
So it would be like A equals.
Okay, so that is a thing. We want to know what the area is equal to, right? Will this right now help me find what the area is equal to?
No.
Not really.
Does that make sense? Okay, so I like the thought, I like the idea of recognizing I can use inverses, but yeah, that's not going to give me area. I want area equals. I want that. Remember, I told you use this equation to get this into one variable.
Can you not do like 50B?
50b.
Area.
I don't know, because you're subtracting B from it.
Okay, we are subtracting b from 50. That's got something to do with it. Let me point this out then. What is 50 minus b equal to? H. If 50 minus b is equal to h,
So,
say that one more time again.
A equals B with 50 minus B in parentheses.
So the b stays there, but then that h becomes 50 minus b? Is that legal?
Possible. Yes.
Oh.
Yes.
Amari's like, yeah, now I can do it, okay. So Lexi, I heard you, I noticed you saying, yes, this is legal. Why?
Because that's what your height is equal to.
Oh yeah, 50 minus b is what the height literally is equal to, right?
Yes.
Anybody know the property that we can use?
Height.
We can now use distribution, but there's another property that we can use. So let's say, I heard someone say it. Substitution. Okay? So like the idea is this. Play until you broke your foot, or they found out you broke your foot, you played tight end. Everything, but tight end was one of those things?
Yeah.
Okay, so if Clay was playing tight end and he was pulled out of the game, what kind of player would they put in at his position?
a substitute.
They would substitute a tight end, right? You're going to put things in that are the same. If 50 minus b is equal to the height, 50 minus b can be substituted in for the height. Now, how many inputs do I have? Just one. So I'm just going to go to this next column. You don't have to type this in, but I want you to notice. So equals b is base 1, right? Now I'm going to put parentheses, or times parentheses, and I'm going to do 50 minus the base. Should I get the same values or different values? Let's find out. Did it give me the same values? Yes? Amari, you mentioned something a second ago that we could do what now? Distribute? What is b times 50?
50B.
50b. And what's b times negative b?
2B. I mean, I'm lying. B.
Okay, it's not negative b. Not negative 2b. Negative b squared. So let's look at this. I need y'all to remember, listen. Negative 2b, what's operation is understood to be in between those? But multiplication is repeated addition, okay? So, Maddie, are you here to work on your test? Okay, I'm going to give you all 20 minutes at the beginning of class to work on it. So just go on back to enrichment, okay? So, multiplication is repeated addition. Am I adding this b and that b? No, that is b times negative b. What operation shows repeated multiplication? An exponent. I have two b's, so it would be minus b squared. Let's check that equation. Equals, what was it, 50 times the base? Minus the base squared.
You said make it, I mean, equals.
So I typed in, you can see it down here, 50 times the base minus the base squared, right? 50b minus b squared. Let's see if it works. Same exact values.
Yes.
I just used the base, okay? And so what I want you to understand, so there's two things out of this that I want you to see. First off, you see how I have an input and I'm getting an output? These are two of the forms of explicit quadratic equations. So, two forms. You do want to take notes. Actually, let's leave this here. You should take notes on how we got from here to here, right? So the idea is that we substituted in.
There's another one.
Okay, hold on one second.
Sorry.
All right, I'm going to give you all 20 minutes in the beginning of class to finish your test up. Probably should. I don't think too many more will come back in. Okay, so substitute 50 minus b in for h, and so make a note that these are two explicit, or two forms of explicit quadratic equations. And we distributed to get to that second one. Well, that was more just so you don't need to know how to put it in the calculator. I was more just showing that those two explicit equations gave us the same exact outputs.
Oh yeah, can you tell me that?
The equation's right here. Remember, b times 50 minus b, so I just typed in base times 50 minus the base. Say again, Zane?
There's classes.
No. We got a little bit later.
Can you put on the grade spot for D?
Say that what?
The grade name for D, the grade spot, so it says for.
It's right here. Base,
I can't see the board.
parentheses 50 minus the base. Y'all don't need that. You need to write down these equations. I'll write them bigger if you need, but you should write down the equations. And if you can't read it from here, or from where you are, Kennedy, get it from a friend. I hope someone in your group can read that far away.
I don't know about yours.
Okay?
Oh.
All right. So again, those are two forms of explicit quadratic equations. Remember, all I mean by explicit is it's relating what two ideas? This is the input and then output. Explicit equations relate inputs and outputs.
What's the output?
The output would be the area.
What you get out of?
So I substitute in for the base, I get out the area. Just like here, you see how I put this equation of base 1 times 50 minus the base? So it took the base that's over here, substituted in to get these outputs for the area. Alright. There's only two things that we still need to cover. Okay? Not sleep is not one of them. I will point this out. The names, I'll just cover the names of those two forms later. I'll say this. You see how these things are being multiplied?
Yeah.
What's the name of things that you multiply? It starts with an F.
Factors.
This would just be called factored form.
I was gonna say that too.
Okay? This has a square in it on the variable. That's known as standard form. We typically write standard form this way. And then there is a constant at the end. That's known as standard. So there's only two things left. One of them will be super quick. Make a new page so that we can graph something. So add a page, and I'm going to go to graphs. There we go. Nice and straightforward.
Oh, wait.
No.
How you get there?
Control doc is how you add a page.
What's
And we want
graph?
to add a graph.
Is that 3?
I think it's 2, my man. Huh?
Ooh.
How come yours
Wait,
have
yours
dots
have boxes.
Uh-huh. I'm about to show you how to fix that.
Boxes?
Boxes? So, this is a grid, not boxes. It's a grid system. To get the grid system in there, what's the one button we always press to make the calculator do everything? So I'm going to go to menu.
Oh, yeah.
What do you think I want to change?
View.
The view. I'm going to try to change the view. Anyone see where we might go to add that
Grid
grid?
6.
Oh, grid. Beautiful. And you want a lined grid.
What's
So-
the dot grid?
The dot grid is goofy. I'll show it to you, but you want lined grid.
You
That's
should-
the dot grid.
Ooh.
I don't like the dot grid.
It's like battleships.
Kind of sure. So you want a lined grid. Now, we want to graph something. Now, we've already written an equation, but before we put in the equation, I want us to learn how to quickly graph a scatter plot. So again, what button am I going to press to do stuff? Menu. Then,
Actions. I'm lying.
You're lying.
we're trying to graph a scatter plot.
Graph entry.
Hey, Emily, I'm going to give you all time during 20 minutes in class to finish the test. Where are we going?
Graph entry.
Graph entry. What do you see under graph entry?
Scatter plot.
Ah, beautiful. I can graph the scatter plot. So click on 6 for scatter plot. We're all caught up, right, Dave? You're not going to ask me to re-say any of that? Okay. Notice how it gives you a place to put your variables. X is your inputs, your independent variable. Which variable do I want to place there?
Base.
Base.
You said independent variable?
Uh-huh. So my inputs are the bases, and what's the output, the Y that I want?
Height. I'm
Nope.
lying. Area.
So height could work, but right now we're trying to look at area. So go to area. Once you have both those in, hit enter.
Oh my gosh.
Now,
What?
how many points am I supposed to see?
Like what?
I'm supposed to see quite a few, right?
Yes.
There's actually 11 of them. But I will also point this out. What's the scale on that graph right now? Scale. It's going by ones and it's going to about 10, right? Doesn't that go up to an area of 625?
So we gotta make that thing higher pretty much.
That thing. I don't know about that thing, but we might want to change what the window is. So what am I going to press?
Menu.
Menu. I'm going to change. Where am I going to go from menu?
Window.
Window.
So please notice, don't click anything yet. I just want you to
Whoa.
notice, listen, view is not where you want to go. Notice there's nothing to change what I'm looking at, it's just how it looks. But when I go to window, you can just change the window settings. You can just zoom in and zoom out. Because I have a scatter plot, the best option, anybody know?
Well,
Not zoom out.
window setting.
Look at all of the options.
Quadrant.
Ooh, that's a good
Quadrant
one.
one.
That's a good one. Oh, never mind.
Data.
I was close.
Scatter plots are effectively data.
Oh my gosh.
So if you zoom data,
It.
look at that. Like we're learning stuff up in here.
Wait, it's not letting me drag my base.
Are you
I have to do
Einstein?
that.
No, I just learned how to do things. That dude's a genius. I'm nowhere close to that.
There we go.
Alright. Does anybody need me to go back through how to do the scatter plot? Alright, Lexi, Leah. So, you're going to hit menu. You want to add, do I need to go back through how to create the graph or just the window part of it? That over here.
Exactly.
Okay. Alright.
Exactly, both of ours do.
I know.
Put your hand back.
They never had Lawrence. They never the light don't crack. It's taking forever. Let's go,
He
baby.
said we don't like
It's because you went all the way past. So it has all of these negatives. It's not necessarily wrong, just leave it for now. You just went too far. Yeah, you just didn't need, you wanted maximum height of 50.